Broccoli occupies a position in nutritional science that is simultaneously well-established and still unfolding. Its basic micronutrient profile has been understood for decades, but the research on sulforaphane, a compound released when broccoli is chewed or chopped, has generated enough mechanistic interest in the cancer biology and longevity research communities that broccoli is now studied by scientists who wouldn't previously have spent much time thinking about vegetables. This is a food where the nutritional story is genuinely still being written. Start with what is firmly established. A cup of cooked broccoli provides 135% of the daily value for vitamin C, 116% for vitamin K, 14% for folate, 11% for B6, meaningful potassium, manganese, and phosphorus, all for approximately 55 calories. The fiber content, 5 grams per cooked cup, supports digestive health and gut microbiome diversity. The nitrate content contributes to nitric oxide production and cardiovascular health via similar pathways to spinach and beets. By most standard nutritional metrics, broccoli is among the most nutrient-dense foods available per calorie in the produce section. Sulforaphane is the compound that has generated the most scientific excitement, and it requires a brief explanation. Broccoli contains glucoraphanin, an inactive precursor, and an enzyme called myrosinase. When broccoli is damaged by cutting, chopping, or chewing, these two compounds come into contact and produce sulforaphane, a potent activator of the NRF2 pathway, which upregulates the body's own antioxidant and detoxification enzyme systems. Sulforaphane has shown anti-cancer properties in cell culture and animal studies against multiple cancer types, and epidemiological research on cruciferous vegetable consumption consistently finds associations with reduced cancer risk, particularly colorectal, lung, and breast cancers. Human intervention trials with sulforaphane are more limited, but include promising findings for reducing aflatoxin DNA adducts and benzene-related DNA damage in high-exposure populations. The cooking method is critical and underappreciated. Myrosinase, the enzyme that activates sulforaphane, is denatured by heat. Boiling or microwaving broccoli destroys this enzyme before it can complete the conversion, significantly reducing sulforaphane yield. Light steaming for 3 to 4 minutes partially preserves myrosinase activity. Eating broccoli raw maximizes sulforaphane production, though digestibility and palatability vary. An elegant practical solution: chop broccoli and let it sit for 10 minutes before cooking. This allows the enzymatic reaction to occur while the compounds are still accessible, and subsequent heat treatment doesn't reverse it. Alternatively, adding raw mustard seed or powdered mustard, which contains active myrosinase, to cooked broccoli has been shown in clinical studies to restore significant sulforaphane production. Thyroid function is the caution that comes up most consistently with broccoli, and it needs to be proportionate. Cruciferous vegetables contain goitrogens, compounds that in very high amounts and predominantly raw form can interfere with thyroid iodine uptake. This concern is almost entirely irrelevant for people with normal thyroid function who are not eating enormous quantities of raw cruciferous vegetables daily. It becomes modestly relevant for people with pre-existing hypothyroidism, in which case varying vegetable sources and including cooked cruciferous vegetables rather than exclusively raw is sensible management rather than elimination. Gas and bloating in sensitive individuals is a more practically common issue, manageable through portion adjustment and thorough cooking.